the pencil for so long. I guess I was afraid of making a mistake and needing to erase, but I hope that this is clear. And I'm going to do my best not to make a mistake, but it's okay if I do because we learn from them. Okay, so we're going to do the area and perimeter problem on page 39. It reads, a rectangle has an area measuring 120 square centimeters. Its length and width are whole numbers of centimeters. What are the possible combinations of length and width? Which possibility gives the smallest perimeter? Work this problem before continuing. So again, it says a rectangle has an area measuring 120 square meters. So I'm going to write that 120 down. Its length and width are whole numbers. What are the possible combinations of length and width? The possible combinations of length and width are going to be factors of 120. So it would be helpful if we did a little prime factorization. We know that this will be 2 times 60, 2 times 30, 2 times 15, 3 times 5. Good old factor tree here. Why am I doing this? Because if we have all of the factors, we can write all of the, if we have the prime factorization, it's easier to make sure that you get all of your factors for that number and you don't leave anything out because you have the prime factorization there. So factors of 120. We have that prime factorization. So let's just go ahead and list them now, but utilizing that as a cross check. So we know that we'll have 1 and obviously a 120 here at the end. We will have a 2 and a 60. We will have a 3 and a 40. We'll have a 5. And let me see, which one am I missing here? A 24. We'll have a 6 and a 20. And we'll have an 8 and a 15. And then lastly, a 10 and a 12. And again, if this is just a nice cross check to have there. This will be good because what we'll do is we'll start to put these different combinations up here for the length and the width because we know that 1 times 120 would give us an area of 120, and then from that we can calculate the perimeter. We're looking for which of these possibilities would give us the smallest perimeter. And again, the only two numbers that we can use for length and width have to be factors of 120 because they have to multiply to give us that area. An area of a rectangle is length times width. So we have 1 and 120, and that'll give us a 2 times 1 plus a 2 times 120, which will equal a perimeter of 242 centimeters. We have our 2 and 60, so that will give us 2 times 2 plus 2 times 60, and that will equal 124 centimeters. We have 3 and 40, so we have 2 times 3 plus 2 times 40, and that will give us 86 centimeters. This is going down. That's good. 4 and 30, 2 times 4 plus 2 times 30 will give us 68 centimeters. We have 5 and 24. So we have 2 times 5 plus 2 times 24, which will give us 58 centimeters. We have 6 and 20. So we have 2 times 6 plus 2 times 20, which will give us 52 centimeters. We have 8 and 15. That will give us 2 times 8 plus 2 times 15, which will give us 46 centimeters. And lastly, 10 and 12, which will be 2 times 10 plus 2 times 12, which will give us a total of 44 centimeters. 44 centimeters is going to be the smallest perimeter to achieve with a length and width of 10 and 12.